Screen is visible?
Yes, sir.
Okay, thank you. Up till now, we have solved the problem using 1D analysis. Now we have to move to the 2D analysis. But for 2D analysis, it is important to learn the 2D meshing. Getting? So 2D meshing we require to learn, and then after we can go for the different analysis. Okay, sorry. Then before meshing, uh, what we will do, we will learn how to import the file. Suppose your modeling file, how we can import into the software, and how we can save it or export it into the different extension. That exercise we are going to learn today. And after that, when we import any file, modeling file, maybe from CATIA or maybe from ProE, into the this particular meshing software, that when we import from one software to this software, uh, that having some errors in that particular geometry. So it is must to clean that geometry. Okay, so that also we are going to learn, that is what the geometry cleanup. So by using different tools and techniques, that we are going to clean the geometry, and that cleaning of the geometry is called as a geometry cleanup, and that geometry cleanup is must before going for the meshing. Otherwise that will create the errors in the result, or maybe when we import into this particular software that geometry file, you can easily find out the some of the errors, like extended surface, some surface will be missed, some surface duplicated. So that kind of errors will be occurred. Sorry. And that we have to remove from the that particular geometry. Okay, so we are going to learn how to import the geometry from the other software. So before that, let me explain you. There is a user profile, and we are using OptiStruct. And if you want to use the radius, here the bulk data option should be there. Bulk data. In the radius, if you select the bulk data, then only it is possible to solve by radius. Otherwise, it is difficult. In this my software, the bulk data option is not available. So last time some of the students were asked me why we cannot solve by radius. So that was the error. So that I have gone through the different exercise, and I came to know that if I want to solve by radius, then here should be bulk data option need to select. Otherwise, you can select by OptiStruct only. Okay. Then first of all, import option. So whatever the file .stp or .igs that you can import from here. So there are import model, import solver deck, import geometry, import connectors. Okay, and here are the some options: export model, export solver deck, export geometry. So there are different kind of extensions. Okay, suppose if I save the file of modeling in the CATIA or maybe ProE, that model file can be saved either in IGS or maybe .stp, and that can be imported in this particular software by import geometry. So by import geometry option, you can import the .igs file. Okay, then import model. The model means whatever the meshing file, model with meshing, that file can be saved with extension of .hm, hypermesh .hm, and that .hm file can be imported by import model. Okay, and this solver deck means what? That file is a final fem .fem or .fa. I think I will check out. .fa file, fem file can be saved by or can be imported by this import solver deck. Means whatever you are going to do in the analysis, maybe load connectors, then boundary conditions, and that can be saved directly by import solver that can be imported into this particular software by import solver deck. So whatever analysis you are going to do, and if you save it, then that would be saved in your .fa, and that can be imported by solver deck. Okay, so that I am going to show you, and that here it is some import connectors. Connectors means maybe the boundary conditions are there, or maybe some elements are there. So that can be imported by import connectors. You can export also that. Okay, so whatever import options are there, same options are available in the export option. Okay, so you can export model file, export FEA file, export geometry file. Okay, so that I will demonstrate here, so you can come to know how we can import or export in this particular software. So if I go to the import, this option is available in the file menu also, import and export, and this here it is a shortcut, import and export. So if I go to this one, then import geometry, I will start with geometry, or maybe I will start with import model. Okay, import model. Okay, so here some already imported file is there, so you can delete it, select it. If you want delete all, there is a one more button, remove all, and remove previous session. Okay, then if you want to go for this import file, you have to go to the location of that file. Okay, so whatever my files are there that are saved in one of the drive. So hypermesh data, then so okay, so here two options are there. So that import model can be that saved into .hm file. So that hm file, if you want to import from import model, so I will use the bumper model here, and I will import that bumper first, mid. If I open it, select it, import it. It will take some time, and it is imported. If you want to display it, you have to click on the fit model. Okay, so that already meshed file is there. Already meshed file is there, import model. Okay, so that can be imported. So import model, we can import the HM file, hyper meshed file. So here is a wireframe mode. Here it is a shaded mode. Then also you can check out here wireframe and shaded mode, and that can be, you can check out here. Okay, so there are two options in the component. One is meshing. If I opt the mesh, two parts are there, center and mid one. So here it is a center and here it is a mid one. So I can opt the meshing also. And this one is a surface. Okay, so I can hide and unhide by using this import option. Sorry, this particular component option. Getting? After that, again I will go to the model file. Then I will remove this one. Again go to the same location, and one more file is there, bumper mid hm.hm. So I will import that one and check out what happened. So we have to fit it. So one more part is added into this one. Initially it was there were two parts. Now one more part is added into that one, and that it is added into the component 3. Okay, now so here you can see here 3 options. I can also opt the meshing from that file. Okay, now you can hide and you can play with this using these panels. So already I have told you, control button you can rotate, control and left mouse button, control and right mouse button you can move. move that particular model. Okay. So here, these are the some options. Now next part, import geometry. So if you go for the import geometry, I will remove this one and I will go to the same location. So if I go for import geometry, you can find the .igis file from the same location. So if you go for the import model, then definitely you will find there .igis. If you go by import geometry, definitely you can find the .igis. But if you go by import model, you cannot get this .igis. When I use first option, there were only two files. One is center mid hm and this hm. So .hm file can be imported by import model, and .igs file can be imported by import geometry. So I will go to this one and I will open that. So this one import it. So you can check out that is connected automatically here, but the surface is not visible. Why it is? Because it is in wireframe mode. So if I on it, so that surface is also going to be displayed. Getting? So this is what the import geometry. Here meshing is not available. For the part number 4, this one. And that can be segregated by color coding also. You can check out here. This color is this part and this color is for this part. Okay. So this is how we can prepare the or import the different options. Now, if I want to import all the FEA file, then you have to go for the solver deck. Okay, so you can check out here meshing is not available because this is only .igis file, .igis file model. Suppose if I want to import the solver deck, so you have to go to this one, then select the .fem file, .fem. So when you go for the solver deck, it is going to it would be only possible to view the .fem file. So .fem, open it, import. So everything is imported. Meshing also imported here. Also some of the connectors. So here ribs are there, that are also here. I mean, these are the boundary conditions and other things. Everything will be open in the .fem file. Suppose if whatever we have saved files, that we have to import by solver deck. Okay. Suppose I will show you. I will take this new file. And if I want to import the solver deck file, whatever we have done analysis, from that I will open. So 1D roll cage. So roll cage we have solved. Na? So .fem, if you open it or import it, if you import it, that everything will be open related to that option. Okay, so this is what wireframe. I will make it. Okay, so it is in 1D mode. So if I want to 3D representation, you can mode it into 3D. Okay, you can check out in the solver deck. In the solver deck, everything will be imported. Even this load step also imported. And you can edit into that one and you can again solve that file. Getting? So this is how we can import the different files. Now, how to export it? Again, I will go to the new file. So I will import again solver deck, whatever the so hypermesh data. Okay, same bumper file I will import. So .fem file is here only. So I will import model also. So simultaneously you can import both the files. Select shift button, select both, import. Okay. So you can check out everything is imported here. Getting? Now, if I want to save this, export this, this is meshing file. If I want only to export the modeling file, then I have to go to this one, export geometry, and you have to select the location where you have to export it. Suppose if I save the geometry with a name at a different location, suppose here if I save it with the number 1, export, so that would be saved at that location. I'll show you. Hello, Aditya Mani. Aditya Mani.
Yes, sir.
Mute yourself.
Yes, sir.
Okay. Okay. So where I'm showing here, this one. Yes. So here HM 1D. Yes. .igs 1.igs. So that file is saved. And if you import it, the same file, if you import, then modeling file can be extracted here. If I go file, new, yes, and if I import the geometry with the same name, .1 IGS, open, so that everything will be open, but meshing is not there. Getting? So that file can be imported without meshing, even though if you check it, the meshing is not there, even though if you on it or maybe off it. So this symbol is representing meshing, this symbol is representing surface. Okay, so 2D means what? Already I have told you that one dimensional is very, very smaller than other 2 dimension. That is, we are considering as a thickness. That thickness is very, very small compared to other 2 dimensions. That's why it is called as a 2D. Okay, and in 3D, all 3 dimensions are comparable to each other. Okay, so this is what we can save, import, export the files, different files with a different extension. Okay, now I'll stop here for this particular model and I'll move to the geometry cleanup. Okay, so everybody, I hope everybody understood how to import and export the file.
हॅलो सर.
Yes, Shreyas.
सर एसटीपी फाईल मध्ये सेव्ह केलं तर जॉमेट्री इम्पोर्ट होते की नाही मग? आपण कसं ANSYS ला करतो ना एसटीपी म्हणजे ANSYS ला ANSYS मध्ये इम्पोर्ट करायचं असलं की एसटीपी सेव्ह करतो.
dot step need to be checked. I think that should be imported, but we can check out. And if it is not importing, then we have to convert this into .igs and then import it.
सर तुम्ही आता जी जॉमेट्री इम्पोर्ट केली ना ते डायरेक्ट मेशिंग कसं काय होत होतं म्हणजे ऑलरेडी कसं काय मेश झालेलं होतं.
ऑलरेडी मेश नाही आहे ते मेशिंग केलेलं आहे आणि देन इट इज सेव्ड.
ओके ओके.
Previously that file is like this. This is prepared in CATIA. Let us consider this is prepared in CATIA. Then it is in IGS format, right? Then it is prepared, that imported, and then meshing is carried out on that particular file, and then it is exported by export model. If you export model, then that would be saved in the meshing format, means .hm.
Yes.
Okay. So that are exported part wise, and then connected each other. So that's why it is showing that. Okay.
Okay, sir.
Okay. Now what I'll do, I will remove this one file, new, and I'll check out with new file, and I will import the geometry. I will import from here also geometry or maybe model. Okay. So whatever, if you import the model into this one, this particular software Hypermesh, and without meshing, even though if you save it, so that can be saved into .hm file. Do remember. Okay. So with at whatever state, if you save at if you save any model in the Hypermesh at any state, that would be saved in terms of .hm. Do remember. If you do meshing or do not do meshing, you will get .hm file. So I will import the model, one of the model. Okay, importing and repairing CAD model. Okay, so there is a clip. It is in .hm file. Though it is in .hm file, it is a geometry file. Means what? Previously, that IGS file is saved, imported, and saved into the .hm. So that's why it is .hm, but meshing is not there. So you can check out whether that meshing is available or not available on that particular file. So you can import. So once you import it, you have to view it. That okay. So this one is a file. It is in wireframe model. So you can make the surface visible here. So this is what the clip file. Okay. So when you import it, you have to check into this one history, whether it is a meshed file or unmeshed file. So how we can check the meshed file or unmeshed file? So if you go into this one component here, if you off the meshing or on the meshing should be visible here. If it is not visible, then it means that this is only CAD file. Okay, CAD modeling. And if I off the surface here, that everything will be invisible here. So this is only CAD file. There is a not meshing. So it is very much related to each other, .hm and .igs. So you have to confirm it from the history here, the tree, and check out whether that hm file or not hm file, means that meshed file or without meshed file. Okay. So after that, what you can do, you have to, when we import the file into this one, you will get some errors into this one. So you can observe here, the extra surface is created here, or some of the surfaces are missing here, but it is not visible as it is. So if you go into this one, by topo, go to the visualization option and by topology. Here different option, by compo, then by topo. So if you go for the by topo option, you will find some red color edges, you will find some green color edges, you will find some yellow color edges. So what is mean that red, green and yellow, that you will get here in the visualization option. Here, if you observe, the red color edges indicating that free edges means that are not connected to each other. So if you observe this part, that extra portion is created here, and this one is one of the error in the geometry. Okay, then this green color indicate that these are the shared edges, means that surfaces are connected properly from this to this. These are connected properly. If it is not connected properly, you will find the red color, means free edges. Here surface is missing. If you observe clearly, here one of the surface is missing in the geometry. That's why the red color indicate. This green color is inside of that geometry. I will show you. The surface is missing, and this whatever the red green color indicating, this line is indicating. If you observe from here, okay. Even though if the surface is not stitched properly, it's not connected properly, then also you will find some this type of red color edges. Getting? I'll show you some of the surface. Look at here. This surface and this surface is not connected properly. That's why these edges are free edges. Instead of one edge, there are two edges and very small gap in between that. This surface and this surface. That's why it is showing the red color edges. And even though if you observe, the inside green color is indicating here. It is inside whatever the backside part that is visible here. So that surfaces are not stitched properly. That's why, or the surfaces are not connected properly. That's why that red color indicating over there. So these are the different options are there. Suppressed, next option is blue color. Here it is no blue color, but sometimes when we divide into this one, this surface, total surface, if I divide into this one, okay, then I'll show you. Yes. So sometimes you will find some this kind of color. This is suppressed. Means what? We can, if I on it, okay, so that is divided into two parts, this surface. And if I toggle it, toggle means that will be suppressed. Hide. So this is a complete one surface. Getting my point? One more thing I will show you. Look at here. This total surface is divided into, let us consider this surface, divided into 1, 2, and 3 parts. And if I one of the line, if I toggle it here, so this is one surface only, and this one is the second surface. Okay. 1 minute, I will connect my charger to the laptop. So getting here, so that suppress means we can, if I click right click, it will be again divided. Okay, splitting. So splitting will be can be done here with this particular line. And then these are the non-manifold. Non-manifold means what? Either that yellow color indicate that either that are overlapped, some surfaces are overlapped here, means duplicate surfaces are duplicated here, or maybe T section would be there, means T section, you know that when we connect the two surfaces, some of the part of the T will be overlapped. Okay, when two surfaces connected, and if I prepare the T shape, so at the middle there would be overlapping. That kind of surfaces are showing by this yellow color. That means that non-manifold. Okay, so this is what the indication or visualization of this particular different colors. So I will convert it into wireframe mode, and you can check out how many yellows are there, how many reds are there. So we have to convert all these into green colors. Green colors are clean geometry. Green colors indicating that these are the clean geometry. So we have to remove this yellow, then this red. Suppress can be accepted, okay, but red and yellow colors lines cannot be accepted. That are errors. So that we need to remove. So there are different options in the particular this hypermesh, so that we can clean the geometry. So what are we step by step we are going to remove small errors. So I will concentrate on only one error. So you can observe here there is surface is extended and the error is created in the geometry. You can check out that part is extended from this one. We have to remove this, trim it. We have to trim this part from this surface. So how we can trim it? So in the geometry there is a surface edit. Option is surface edit. Do remember this option, surface edit. In the geometry page, you have to find out the surface edit. Okay, and go to the trim with lines. There are many options, but here you have to select the trim with lines. Okay, and then select the surface here, trim with lines. Click on the surface, select that surface where you have to trim. That total surface will be selected, and you have to select that line from where you have to trim. So I have to trim from this curve. So that line you have to select. What I have done, first surface select, then line select. Click on the line, select the line, and just click on the trim. So that there would be two separate surfaces. Initially it was a one surface total. So we cannot delete this part. So we have defined these two separate. Okay, so you can delete this surface. So you can go for the delete option here. Here you need to select the surface option, delete surface. Select the surface which you have to require to delete. I can select this one and deselect by right click. Selecting by left click, deselecting by right click, and then delete the entity. Okay, so that surface is deleted and the geometry is clean. Now still it is not properly clean. So here you can see here this surface and this surface is not stitched properly. Stitched properly, not stitched means not connected properly. This and this is connected properly, but here some gap is there, very minute gap is there. We can see by even if I make it zoom. Okay, very minute gap. So here you have to go to this one return, and you have to go to the geometry quick edit. So surface edit and quick edit. By these two options we can clean up the geometry. Most of the geometries can be cleaned up by these two to three options. So quick edit, and here you will get toggle. Toggle means what? We can stitch that surfaces or line. Okay, so here click on the line, and here you have to put the tolerance value. Tolerance value means up to 0.1 we can stitch the gap. So we have to give the 0.1 tolerance value. You can increase also. So here it is a very small gap, so I will put here 0.1. So if I click that line, that would be toggled and it will be converted into green one. So still there are many lines which can be toggled. You can see here, very minute gap is there, very minute gap. So I can stitch that one. Okay, so whatever the red colors are there, that I can stitch. But here if you observe, the surface is missing in this one, because you can see this rectangle surface is missing. So how we can fill that surface? There is option filler surface. Below of that toggle edge, in the same option, geometry, quick edit, filler surface. Click on the filler surface. Okay, and just click on any one of the line. So that surface will be filled. So that surface is automatically filled. Getting? So this is how we can remove the. Here also the surface is missing. If you observe properly, look at here. The gap is there. So you can use the filler surface here. So that surface is filled properly. Okay. Now, if you observe here, we have to use the toggle option. or surface pillar option? Which option we have to use here? Which one? Whether toggle edge or surface pillar for this? Let me know. Just on your mic and tell me.
Toggle edge, sir.
Toggle edge. So we have to use the toggle edge here because filler surface cannot be used here. So I will use the toggle edge here. Go to the toggle edge and click on that one. So automatically it will be stitched. Sometimes if it is not stitching, it means that the tolerance value is wrong. So we have to increase the tolerance value here. Okay, if it is not filling. So I will put here 0.1, 0.1 with this we can toggle this. So I will toggle this edge also. So properly need to select, then and then only it can be toggled. So this also toggle. So many edges are required to toggle. So that I will toggle it here. Also this one, look at here. This is not stitched properly. You can look now. If I click it, it would be stitched properly. This is connected properly. This is how we require to use the toggle and surface pillar for removing the red colors edges. So I think all the red color edges I have removed. Now there is a yellow color edges. Okay, so that how we can improve that yellow color. Yellow color indicate that either it would be T junction or maybe surface are overlapped. Surface or overlapped means what? Same surface, duplicate surface is created on the same surface, and it is happening while transferring file from other software to this particular software. So that even though if you import the CAD file into ANSYS one, still we required to remove some errors or improve the geometry. So same way here also we require to improve the geometry. So that yellow color indicating that there is no T junction because there is no any other connection, okay, at the mid. So definitely the surface are overlap. So I have to go to the delete option and select the surface. This surface need to select and delete the surface. So automatically that would be converted into green one. Why it is converting green one? There are overlapping of surface, and if I remove the first surface, then there would be only one surface remaining, and that's why it is clean geometry. Okay. So for this one, we require to remove the duplicated surfaces. So that would be converted into green one. Next part is what? We have to check out whether all the errors are removed or not. Whether all the errors are removed or not. So how we can check out? Go to this one. Okay, and you can check out. We can off this one, everything, and just on the red color. There is no any red color. Even though if I on it yellow, there is no any yellow one. Suppressed also not there. All are green. Okay, all are green there. So that's why it is clean geometry now. And now you can do the meshing on that. Now you can do the meshing on that. Getting? So while doing the meshing, while applying the meshing concepts here, it is must to check out the thickness of this particular figure or geometry. So if you observe here, there is some thickness. Okay, and we cannot neglect that thickness. Having thickness 2 mm, 3 mm or 5 mm, whatever it may be. Okay, so we cannot do the meshing directly on this particular geometry with this particular thickness. So in the 2D meshing, where basically we are using shell elements. and that shell elements that are like surfaces getting. So if I apply the 2D meshing on this particular surface, so that applied only on this top surface. Okay, so that would be very wrong. Getting my point? So that's why we have to extract the mid surface of this particular geometry. Mid surface. We have to extract the mid surface from this particular geometry, means that we have to neglect the thickness of this particular geometry at the start of the meshing. And after that, we can apply the thickness to this particular geometry while giving the or while doing the analysis. Getting my point? Means what? We can 2D means only there should be only surface. This geometry can be solved by, or that can be what we can say, that meshed by 2D or maybe 3D. But if I want to go for 2D meshing, there should be only surface. And in the 3D meshing, the thickness is directly considered for in the during the meshing. But in the 2D meshing, thickness will not be considered in the meshing. That would be considered at the time of analysis. We have to put the value directly. 3 mm thickness, 5 mm thickness. In the 3D meshing, it is not required. Getting my point? So it is must to extract the mid surface of this particular geometry. So how we can extract the mid surface? The 2D option or geometry option. In the geometry, mid surface option is there. Mid surface. Extract the mid surface. Extract the mid surface. So I have to extract the mid surface. Go to the mid surface. In the mid surface, we have to select the surface. Okay, surface. So, and we have to select the auto mid surface and select the whole geometry. So how we can select the whole geometry? Shift button and click. Okay. Here close solid, that geometry should be closed, and extract. So if you observe, one red color line is displaying at the middle of this thickness. Okay, let us consider if it is the 5 mm, that 2.5 mm from this one surface is extracted, and that is generated. And how we can view that one? Look at here. Okay. So I have to go to the model. Here it is a mid surface. If I off this model, it is a whole geometry. Okay, this is a whole geometry. Meshing is for that whole geometry. And if I off this one is a mid surface without thickness. So only surface is there. Okay, it is like a removing one of the layer of that particular geometry. So I have removed middle layer of that particular geometry. Slice, you know, slice from the bread, middle slice from the bread. Okay, so bread, when you observe bread, okay, so if I remove the middle surface of that particular bread, so that is what the mid surface. Here it is extracted. Okay, if I on it, everything you will find. Okay, you can see here, it is exactly middle of this one. Okay, so on this surface, this surface, we have to do the 2D meshing. So how we can do the 2D meshing? I'll do some auto mesh here. Go to the return. Now let us assume that this geometry is cleaned properly, and then I have to mesh it. So how we can mesh it? That I'm going to show you here. So 2D meshing, getting here, and then I'll go to the auto mesh here. 2D page, auto mesh. Auto mesh means it will automatically mesh. Here you need to select the surface. Okay, need to select the surface. Instead of automatic, you have to select the interactive here. Interactive. Okay, there are element size. Element size 2.5. I will put it here. And there are some different types of elements. Chord element, tria element, mixed type of element, chord and tria. Then R trias elements are there, and then chords only. So these are different types. I will select here mix type. Okay. Then select the surface. If I select single click, that surface will be selected. And if I press the shift button and if I drag the left mouse button, then whole surface will be selected by pressing shift button. If I click on the mesh, that would be meshed. Get here how it is meshed. So if you want to change it, you can change here also. Here number of options are, number of elements are 2. If I increase the 3 and if I mesh it, that would be 3. Even though I can increase the 4 also. Just click on that number. So that would be increase. So likewise, we can increase the number of sizes. And if I go to the return, so that would be fixed. Okay, here is like this, and that is meshed. Now, if I off the surface, that would be meshed like this. Okay, so it is a meshing surface, meshed only. Okay, get here. If I on the surface, that will be set. Here you cannot, if I off this one, you cannot get the meshing here because it is extracted middle surface from this one and new geometry is created here. Getting here, whole geometry is there. So if I off it, everything will be off. If I want only meshed surface, this would be meshed surface. And if I want meshed surface with the surface, then this would be like this. So I can delete the elements also. Huh? I'll show you how I delete the element. If I go to the delete option, instead of surface, you have to select the elements option. Okay. Here you can select the elements by clicking the drag button and whole elements you need to select and delete entity. So you can see in this one, even though if I on the meshing surface here, that elements are not visible here. Okay, so that elements are not visible. Getting, if I off this one, everything will be off. Okay, so here this one is a meshing surface, so that will not affect on the geometry if I delete the mesh. Now, one more option is there in the 2D meshing. Go to the auto mesh. Instead of interactive, if I select the automatic and if I select the surface, whole surface, I select the whole surface by pressing shift button, and if I mesh it, that would be permanent mesh. We cannot change the options here, number of elements here. Okay, we cannot change the number of elements here. Look at here. Here the meshing is not picking up the geometry properly. So that's why if I on it, some of the geometry is visible here. On the curvature surface, that meshing is not proper. Okay, because this is a chord type of elements. So we cannot divide this curvature surface, curved surface in a proper, what we can say, chord elements. So that's why it is not properly meshed. This not captured. That software is not capturing curved surface properly. Okay, so if I off this one, then it would be that already I have told you this is an approximate solution, right? So most of the errors occurred in the result due to the meshing. Okay, so that software is going to consider the geometries like this, and then it would be then it calculate the result. Getting? So here you can observe. Now still there are some options. If I reject it, reject. Reject, return, not rejected. So again I will delete the elements. Here you can select the element by displayed, means everything will be selected. Delete. Now 2D meshing, auto mesh. Instead of automatic, if I go for interactive and if I mesh it by selecting the surface, I can select the surface, click on the surface by displayed. Displayed means whatever displaying on the surface that will be selected and mesh. So you will get the option in the interactive. You can change the number of elements, but in the automatic you will not get the that particular option. Getting? And then return. If you go for the return, that will be saved properly. Okay, so this is what actually meshed file by using automatic option. So this is one of the option, right? Now still this meshing is not acceptable. Means what? You will get the result, but that results are not very close to the actual one. So that's why we have to improve the mesh again and again. We have to make the improvement in the whatever the existing meshing. And if you improve the meshing, how we can check the quality of meshing, there are some quality criterias that we are going to discuss in the next session. Quality criterias to check the quality of the meshing, and that on the basis of that we are considering or we are selecting the meshing for the right. So here this meshing is with a automatic mesh. Okay, some these holes are converted into like a square. You can observe here when we do the meshing. So these small holes will not affect the result or will not affect the on the analysis. So this we supposed to remove this kind of small holes, blowholes. Okay, that it depends upon the your assumptions. Even though if you observe this circle is converted into hexagon like or octagon like. Okay, so that cannot capture the geometry properly. So sometimes we require to remove that small holes, or maybe sometimes you can observe here the curvatures are not captured properly. So small curvatures, even though if you observe here, this curvature is not properly captured. So it is better to remove. How it is meshed? It is like diagonally it is meshed. So it is better to sometimes remove that kind of small curvatures. Okay, curve surfaces. So by using that, by removing that kind of small curve surface, blowholes, or maybe small holes, keyholes, we can improve the result, or we can improve the what we can say that meshing quality. Okay, so what I will do, I will go to this one more option. I will go to the return and I'll delete the meshing. Or even though what I will do, I will take the new file here. Same file I will upload, import model, same whatever file, the existing file is displaying here. So I will import it, display option. Okay, so this is what the file. For viewing this red color, yellow color edges, we have to select the biotopo here. Okay, now whatever the process we have done with manually removing the cleanup, the whatever the geometry we have cleaned up, that by manually we have cleaned up. There is a one more option, that is auto cleanup. So whatever options we have done by manually, the same option can be, or same processes can be done by this auto cleanup. So that option we are going to learn here now. So how we can see the auto cleanup? Check out here, auto cleanup. Go to the auto cleanup. There are some fixed criterias for this particular auto cleanup, and that parameters we can edit by using edit parameters, or we can set as by default as it is. And target element size parameter is 10 here. Then what we can do, I will select the surface here. By display the surfaces are selected and set for auto cleanup. So it will take some time, and the geometry is auto cleaned up. So you can check out that is removed. This part is removed here. Some of the edges are suppressed. Whatever the extra parts are there that are suppressed here. Only one part is not stitched properly here. So here we require to fill the surface. It is not filled because of our criteria. Some of the criteria or tolerance values are given in the parameters. That's why it is not stitched properly. So we have to go for geometry and then go for the mid surface, not mid surface. We have to go for the quick edit and we have to go for the filler surface and we require to fill that surface. Okay. So some of the edges also not cleaned properly. So here toggle line 0.1. Here also we require to make the toggle. Okay. So I think all the other part is removed from this one. And now we need to check out whether removed or not. So if I opt this one, so you need to check out free and non-manifold. So red color and yellow color you need to check out. Getting? So here it is cleaned properly now. So we can save the time. Even though if you observe here, the holes are also removed by auto cleanup. There is option remove the holes up to 3 mm diameter or 4 mm diameter, or maybe range would be given up to 10 to 15 mm diameter. That kind of options are given into that auto cleanup, and that are removed holes in whatever we have seen in the previous geometry. Now I have to extract the mid surface from here. Select the surface displayed and extract. So once you extract it, the mid surface is created of this whole geometry, and just do the auto meshing by 2D patch auto mesh with the same option. You can select the displayed and mesh it. Now you can check out here. We have meshed in a better way by removing some holes, or maybe some removing some curvatures, or maybe some removing some whatever the errors got in the geometry, or by suppressing the some of the edges. We can get the good kind of meshing quality. So I think it would be better than whatever the previous one. Okay, so this is how we have seen here today geometry cleanup and automation. The next session we will try to improve the mesh quality and how to check the mesh quality, that we are going to check out from the check out in the next session. Okay, so we'll stop here. So if you have any query, you can free to ask. Otherwise, I will take the attendance. Okay. Nikhil is there. Nikhil.
Present, sir.
Then Abhijit. Kaustubh. Kaustubh is there. Rutuja.
Present, sir.
Udesh.
Present, sir.
Shreyas is there. Then Kumbar is there. Patil Zai.
Yes, sir.
Thorat.
Yes, sir, present.
Rakesh.
Present, sir.
Dan. Londe Pawan.
Yes, sir.
Anjali is there. Prashant.
Yes, sir.
Ani Aditya is there. Then Shubham.
Present, sir.
Ganesh. Mahadev? Mahadev is there? Toramkar? Okay. So we'll stop here. So what I will do for the tomorrow session, I'll just off the recording here.